All right. Here we go. So I know it's silliness. We're really slowing this down, man. You complain right now that this is hard. I don't know what to tell you. But we are going to do two methods today. Um, and yes, it is just so weird that every method just has one minor difference. And then probably in two class days, I'll share that historical document of how many times the different methods were used. Some were not used at all, but they were discussed. Blah blah blah, and it is weird. But anyway, and then, like I said at the beginning of the chapter, it's your job to remember when you see this name of this method, what did they do? Okay, so there's the Adams method. First thing is it's a divisor method. So we must remember what that means is when you get a fail on the first divisor used, you must modify the divisor, and that means it's a trial and error scenario, and that is why the calculator is the best way to do that because it does make it faster as opposed to, you know, think of the question in the quiz yesterday. It was I don't know how many states there were at the time of 1800, but there was a lot of them. So if you have to modify the divisor and then guess and check, all you want to do is move along the columns in your calculator and do that, dividing by different things here. Okay, but here's the thing with atoms. It is not round mathematically. It is a round up. So that means if you get a quota that's equal to 12.1, Adams said, let's make that 13 because it went over 12. This is actually mathematically called a greatest integer function for those that were in high-level math classes in the day. And actually in CAT classes, we did talk about really small, the greatest integer function, but it doesn't matter. So anytime you get a decimal, you throw it to the next highest number. That is not rounding mathematically. That's what Webster would do. Webster would have made that 12. Webster would have made this 13. Adams makes these both 13 because anytime a decimal goes past the previous whole number, then you throw it to the next number and then you proceed from there. Okay, that's it. That's the Adams method. Hey, this should look familiar, and I made a management decision. Let's just take that one that I gave you for the review, and I loved. I don't know if I did it accidentally. I think it might have been accidentally. Where in the review for this previous quiz of the four methods before, let's review them. Hamilton, Lowndes, I'm going to freak out. Jefferson, Webster, okay? Four different things happened, meaning a different state ended up with the extra representative. And I found that kind of cool. But anyway, we're going to do this with the atoms. Oh boy. Oh boy. Here we go. I'm glad this is being... Am I taping, by the way? I hope I put the thing running here. Stunning video. Oh, for the love of dog. All right, let's... yes, okay. Stunning video. Okay, so I'll give you a chance to write that chart down if you so desire for your notes. Resume. Okay, so the first thing I did is put them in my graphing calculator. Review again. You hit Stats. Edit. I cleared out all my lists, and then I put the country in question here with the states thrown in there. Okay, but before I continue, shucks. I didn't add. Did anyone remember from the review doing this? What is the total here? 3,385,000. Okay, is that correct? Do you just remember that? Yeah. Really? Anyone else recall that? No, I added it. Oh, you did add it. Okay, so you started the problem. And then what we need to do is take that divided by 3. Did you already do this? 385. This is always the first step in all of the methods. This is how many we're giving out. And what did you do that yet or no? We'll get that figured out. All right. And then what we're going to do is we're going to move this up, move this out here, move these lines so I have spaces to do this first divisor. So we call this first Q, our first quota. And then I'll write the decimal, and then I'll write the rounded version right next to it. And hopefully I can still see my calculator screen while doing that. I move into L2. Again, this is teaching those that still don't know how to do this. 1014.79. We're going to divide L1 by 10,014.79. Okay, good. Enter. Wish I could pull that screen, but I'm going to write it. Oh boy, here we go. So we got 89. Let's do this. See if I can. Yeah, there we go. Move this over a little bit this way. All right, now we're rocking and rolling. Even 89.06, that goes to 90 in the Adams method because it is a click over that nearest decimal. What do you think we're going to be when we have this quota added up? Above or below what we're supposed to be having? Above. 43. 66.3 equals 67 according to the Adams method. 116, oh man, 116.03 sadly does become 117. 24.3 does go to 25. Okay, we'll add those up and then make our next move. This ends up being 342. Okay, and we are only supposed to have 338. So we need to subtract 4. Now, I guess mathematically, the way to think about this, we got some problems because 3 of them are 0.3s. But I could probably see that the top one and the 116.03, just on a little decrease of the divisor, will flip over to the other side and be 2 less. All right, but I need 2 others to fall out. So this is where we got to make a guess. And I don't even know what worked last year. So the first one I'm going to try is 9,000. Okay, again, wrong. What do we have to do with this divisor to decrease this number? We have to do what with the divisor? Increase it. So I did a mistake on that first thing that I said. So this needs to be higher. And that's what I want you to write here for this modified quota. What is the divisor? So modified quota, what do you think? How about 10,100? Want to give it a whirl? What the heck is going on here? Oh my gosh, why does this thing pop up here? Close. What? I did not jeez. Okay, so 10,100. This is what I run through every single day. All right, and then move over. This is why I have a hard time making videos anymore. Random things happening. Second L1 divided by 10, 100. Whoa. Slow down there, Sparky. Okay, and then press enter. Oh, come on, baby. Let's go. 88.3, 41 point. What's 41.8 become? 41.98. What does that become, everybody? 42. This is, what's 88.3 become? 89. So I lost 2. What's 67.6 become? Or 0.7? Help me, help you. 67. And then 24.059 becomes what? 25. So I'm going to write these real quick. 88.3 becomes 89. I lost 1. All right, so this isn't going to be great. 41.98 becomes, I'll just put 0.9 even though it's not really. That becomes 42. I lost 2. Now I'm at 340. 65.7 becomes 66. I lost, I don't know why I wrote equals. I lost 3. Then here's the real bad one, 115.05. This becomes 106. I lost my 4. Hold on, did this work? Oh, 116, sorry. And then this one does end up right at 25. Did I do it? It's a miracle. Okay, so I did lose my 4 seats that I wanted, and barely 24.059 is still 25, so now we're at 338. So I got lucky. Got very lucky. I lost 4 seats, so I know that these add up to 338, which is what I'm supposed to end up giving out. So again, trial and error, multiple answers work up there. You just got to find it out and find out which ones do. Okay? All right, so we got success on that one. Whew, okay. Where's the pause there? Okay, the last of the methods. Is it fat or macked? This is the one that they're using right now, and I think if I remember my documents that I stole off the internet, it's been being used since the 1940s. I think it was first proposed in a shade before the 1920s. All right, and I don't know who Hill is. I think in our document it'll say. Okay, it is a divisor method. Okay, so remember all the divisor methods started with Jefferson, then Webster, then today's Adams, and today's Hills. Okay, so all four of them are divisor methods. That means you have to modify the divisor if you don't get what you want at the first try, and it's a trial and error guess and check. So 4 divisor methods. All right. Okay, and instead of rounding, there is no rounding. You hold that decimal, whatever you see, and you compare it to what's called the geometric mean of the two integers that the decimal is in between. If the quota is greater than that geometric mean, you will assign it to the larger of the two integers that it is in between. If the quota that you are looking at, whether it be the original or the modified quota after changing the divisor, is less than the geometric mean, then you go to the lower of the two integers it's between. For instance, let's pretend that you do a little situation, and this is some state's quota. Here is what geometric mean is. All right, first of all, 15.5 is between 15 and 16. So what you do is multiply them and then take the square root of those two or that product. And that is what a geometric mean is mathematically. Okay? And then that's what you compare 15.54 to. Okay? And now I'm going to go ahead and hit that on the calculator. Second quits. I do have the same states for our example, so we'll get to use our calculator fastly on this. But anyway, 15 times 16, and then the square root of it is 15.491. So this equals 15.491. This is larger than this. So the quota that this will end up being is 16. You go to the higher of the two that it is between based off of this comparison. And that is all you have to do mathematically. Now, I'll show you how this works in the chart. It's really not too bad. You do have to calculate all the geometric means for each state, but then you usually only have to do it once, even when you have to modify the divisor, because your decimal usually stays in between the same two numbers. And I'll show you what I mean by that when we get to it. Just another example, 22.19 is, pretend that's another state that you have on your chart. Well, that is between 22 and 23. And all you have to do is take the square root of that and look at that product. All right, and when you do this, you're going to find out that wrong, second square root, 22 times 23. These decimals usually end up being 0.4 something. All right, and you'll see that as you go through this. But 22.494, 22.494. This number is less than the geometric mean. That means this quota will be assigned as 22, not 23. And that's basically all you have to do. All right. The first step is always the total population divided by how many seats are given out. That's your standard divisor to start off with. So we're going to have the same thing that we had the last example. Can anyone look at the last example and what were the quotas based off of that standard divisor? What were they? I need the decimals. Oh, here we go. This is when, you know what? Screw it. I'm just going to go. And yes, I said that on the video. You just all just sit there right now. I'm going to grab these. Yeehaw! Okay. How do I copy? Just hold on. I don't think this has to be. You know what? I don't have time to stop the video. So control copy. I hope that works. Oh my gosh, because no one will answer any questions for me. I'm all alone. No friends. It feels like at home, Hey, honey, what's for dinner? Go sit in the corner and shut up. All right? Yes, dear. I love you. Shut up. All right. Okay. Oh, I should have done something. Hold on, everybody. All right, this is fun. This is gonna inspire like an extra couple views. There we go. Oh yeah. All right. Okay. So now here's what you got to do. And like I said, you really only need to do this once. And I'm going to put it in colors. Maybe. Okay, but we can't make any decisions yet until we get the geometric mean, for each one of these, and we have to calculate it and write it here. Okay, so I got the key parts of these decimals, and I kind of know where this is going to go because the geometric mean, you'll see what happens with this. But for 89, I have to calculate the geometric mean of between 89 and 90. So I have to take the square root of 89 times 90 and press enter. Okay, so I could do that on the calculator. I'd ask someone to do that, but I know the result of what would happen. Okay, so 89 times 90, I got to calculate it, and I get 89.498 is good enough. 89.498. This is smaller than that, so this will be assigned 89. Got it? This is how this works. I'm going to shut off the video and do the rest, and then you'll see online the result of this, and then what do we have to do about it. Okay? Okay, we calculated the rest. I didn't write the work down. I think you should be able to understand that for 66.3, I did the square root of 66 times 67. And all these rounded down because all of them as decimals in red are lower than their geometric mean comparisons. And with that being said, we ended up having or being one short. So what should I do with the standard divisor? What should I do? Should I increase it or decrease it now that I'm below what I'm supposed to be giving out? What's that again? Decrease it so that it'll go back up. And do we have anyone that's really close? Again, it's going to be one of these three. It's going to be 42.3, 66.3, or 24.3. That's going to flip the other side. And I don't really need to lower this too much. And this is why we don't have to keep calculating geometric mean, because I bet you these are going to be between all that, these same two numbers, and we'll see that. So what do you think? Like 9,950, maybe? Sure. Okay. All right. Just looking for verification. I want everyone to, feel involved. Just me making all the decisions here. All right, and then we can make those comparisons really fast because I feel like this is taking a bit longer than I wanted to. But stat, hey, good thing I had this here, and good thing I used the same example. And this is from the last example, so I'm going to clear that out. I could just rewrite it or just overwrite it. Enter. All right, and then I'm going to go back up, and we're going to take L1, second L1, divided by, I'm nervous, hopefully, what did I say, 9,950. So I just decreased it by like 75, because it was, or 65. It never was 64 point something. Let's see what happens. I can make these comparisons right away. Oh, no. Okay. So what happened with 89? I think I went too far. Okay. Look at the comparison. What's 89.6? It's still between 89 and 90. So what does that do for this? Okay. What does that mean comparatively? Is it going to go up to the next one or stay below on 89? Well, this is bigger, so here's my first modified quota, all right? And you want to tell me what I use. What did I use again? 9,950, is that what I used for my modified divisor? Okay, and I ended up with 89.6 for this. Sorry for so shaky, which is bigger than this, which means this would equal 90. It would flip up to the other side. All right, hopefully no others flip up or else I screwed up and I went too far. It was like so minuscule on the change. Next one, oh crap. I got 42.6 for this. It's a poor choice because now this is 43. I'm already up 2 on this. Now I'm over. All right, so my modified divisor, I went too small. I probably should have just done 10,000 right on the dot. Okay, and then 66.7. Oh my gosh. That one goes up to 67. Now I'm up 3 from the previous one. Every one of these went up except the 24.422. That's strange. Okay, so I'm not sure how that happened. But 116.8 which is 117. All right, and then this one is 24.4. So it went up a little bit, but 4.2 is smaller than 0.49, so this one stays at 24. So this went up 4, which means we're at 341. I'm 3 over. Oh, okay. So now I got to do it again. And notice what I mean about you didn't really have to recalculate these. The numbers still ended up between the same two numbers, so I didn't have to recalculate the geometric means. I just compared it to this column yet again. All right, we'll go offline. I think 10,000 is going to work, and I'll probably just reference it. Actually, we won't. I'll just do it up here, and then you'd have to write it, and you get it from there. But let's see if 10,000 works. Second L1 divided by 10,000, and then all I needed from my first check is only one of them to flip over, and it may be tough, but oh, it doesn't work. Look at that. 89.2 goes to 89. 42.4 goes to 42. So I needed just a little bit more. This is where it gets annoying. 66.4, so close. 66.49. So that doesn't quite make it. So this is still at 337. So you can see what I'm comparing here. And I wouldn't be mad if on a test you're like, I'm not writing that one. All right, I'm going to write the next one. So what do you think? Let's divide it by second L1 divided by 9,000. What do we do that one? 9,950? Is that what it was? Boy, I don't know. 9,990 990. Enter. Let's try second. Oh wait, hold on. Oh gosh, this is so embarrassing. Oh, I hit the wrong thing. Now I'm freaking out, man, because nothing's working out like life for Mr. Samuelis. All right, second L1 divided by what did I just do? 9,990. So should I do 9,980? Okay, 9,980. Hey-oh! All right, who moved up? Which one ended up going up one? All right, and you can probably barely see the screen, but it's when I did 9,980. All of these stayed at 89, 42, but you can see that this 66.5 is bigger than 66.498. So this is the only one that went up from comparing it to that one. So that's the thing that you need to go through. 166.43, that stays at 116. All the other ones stay. All right, 24.349, that's 24. So now we hit the 338. Hi! Okay, that's why we want to use a graphing calculator in the list feature, guys. Being honest. All right, stunning video.